What will happen if from this moment you can no longer see anything around you? You will feel overwhelmed and insecure, right? Do you know that there are currently more than 2 billion people in the world that are living with visual impediments? Hello, my name is Maria Paula and I've been working on a project that combines IoT and physical principles to help reduce the risk caused by accidents that are threatening the life of blind people so that they can have a better quality of life. But how can we do this? Using ultrasonic waves. Sound waves are everywhere around us, even if we cannot hear them. Each wave follows a series of frequencies that are the number of cycles a wave complete in a unit of time. This unit of time is typically taken to be 1 second. This can be observed in the trajectory of a sound wave, which shows how the amplitude of the variable changes within time and describes a repetitive oscillation. There are three types of sound frequencies. Human hearing can respond to sound frequencies that are between the range of 20 Hz and 20,000 Hz. This is known as the audible range. Frequencies that are below human hearing are called infrasounds. These types of frequencies are used by animals such as elephants and whales to communicate over long distances. Frequencies that are above human hearing are called ultrasound. Those types of frequencies are heard by dolphins and bats. But these types of waves, we can use them to measure distances. An example of ultrasonic waves is echolocalization that is used in bats, in which they emit a sound wave that bounces off an object and returns an echo that provides the information about the distance and size of its prey. In the same way, I apply this principle to help minimize the risk of accidents in blind people by using an ultrasonic sensor that sends and receives ultrasonic waves to calculate the distance between their position and their surroundings, so that the person can be warned before he approaches the object. This sensor will be designed in a small size so that it could be implemented at the bottom part of the guide stick. An additional functionality is to allow the relatives of the blind person locate him in a geographical area. This is through the use of a GPS chip integrated with the guide stick, which will report the location in real time. To activate this function, this technology could be implemented with the ultrasonic sensor and also using other innovative technologies such as IoT. After the family member has scanned the code that comes with the guided stick, it will take them to a page where they will create a profile, so that when it is necessary to locate the blind person, the family member will proceed to enter the previous created ID, and by using a connection of GPS to a network, it will show them the current geographical location of the guide stick. To see the operation of the ultrasonic sensor that will be implemented in the guide stick, I create a simulation that shows the technical design of the device using Arduino. The components that I used to create the environment of this device were the Simulino plate, the ultrasonic sensor, a potentiometer, and a virtual terminal.
Now I will explain how the different components are incorporated to activate the required functionality. First, I place the Simulino plate, then the ultrasonic sensor. I connect the central parts Trino and Echo to the Simulino plate. After that, I connect the part Simpin to the potentiometer, which is connected to the ground and to the positive connector. Then I install the virtual terminal, which is going to show the distance measured from the nearest object. This program works by first the pin trainer sends a signal pulse that starts to measure the distance according to the amplitude range indicated by the potentiometer. Then the second terminal, echo, returns the pulse to the microcontroller. These actions can then be viewed through the virtual terminal, where it shows the distance measured by the time it takes for the ultrasonic to travel from the metered to the object and then back to the sensor. By incorporating this technology and learning more about IoT and other innovating technologies, this prototype can be produced and create in each person that is blind and their families a sense of security, just as the one that we have when we open our eyes.